I hope you're here not only because the AC is working, right? You actually want to learn something, right? Good. So as I was introduced, my name is Dmitry Kvasov, and I actually not that much political scientist. I'm actually a game theorist. I got my PhD at Pennsylvania State University quite some time ago. I used to work in Australia and New Zealand for some time, and I've been here for 10 years. And it's actually the first time they allowed me to use this room. I don't know why. This looks such a nice room. Right. Anyway, so what we will talk today, we talk about the mathematics of democracy. And I would stress both words, right? So we will learn something about democracy, and we'll also learn something about mathematics, hopefully. Right. So let me start with a quote by Winston Churchill, who said that democracy is the worst form of the government, except for all those forms that have been tried from time to time. He, of course, was joking as usual with him, right? Indeed, democracy is probably the main way most of the countries function today in the world, right? And at the heart of every democracy is a very, very simple idea. When society needs to make a decision, it's not president. Well, sometimes it's a president. It's not, oh, sorry, you're not allowed to film. Right? So it's society as a whole should decide, right? People should decide. So how exactly should they decide? What is these voting procedures, right? So idea again seems very simple, right? Everybody has a vote. Everybody comes to the voting post, casts the vote, votes are counted, and winner is declared. Whatever happened, maybe there are some different details, right? In different countries, the ballots are written in different languages and so on and so forth. Well, if you actually look at the actual elections, you will see that matters are not so simple. And the difference is not even in the simple details. So this is the ballot from 2024 US presidential elections. It's very congested, but it almost looks like what we just discussed, right? So if you look at this part, here to here, it's actually lists the candidates, candidate for the president and the prime minister and vice president, and you can fill in one of those ovals indicating your choice, right? Except for one interesting thing, it's not in every state, but in some states, there is this thing which is actually write in. You're allowed to write in the name of the candidate, right? Interesting thing, right? But it almost looks like what we expect, right? You come to the poll, you choose the person for whom you want to vote, fill in the blank, drop the thing, then it's counted, and everything is simple. Okay, so let's look at this one. So this is New Zealand parliamentary election. And what happens in those elections? You have now two votes, as it says on the top. You have two votes. And you're voting for the same person, basically. Well, it's tricky. What you're voting for is at the same time you're voting for a person and for a party. It very often, depending how you count the things, what could happen, that the candidate you voted for on the right, the person, did not get in, but it still gets in on the party list. So it already becomes quite complicated. And as you can see, it's not one vote. It's two votes you now giving, right? Is that clear? Good. Next one. Sorry, as I told you, I used to live in Australia and New Zealand. That's why I use examples from those countries. But the previous one also used in Germany, for example, for the parliamentary elections. And this one is also very popular all around the world. So what happens in Australian parliamentary elections? This is really very complicated. What you have now, first of all, it's only part of the bulletin. Usually it's 3 times as long, right? And what you need to do now, you have 5 votes. But it's not just the votes. You not anymore fill in the blank and put the knock or anything. What you do, you put numbers from 1 to 5 in those boxes, right? And 1 means that the candidate you like the most, 2 candidate you like second, and so on and so forth, okay? So as you can see, real elections are a little bit more complicated in some situations than we initially thought. Couple more slides. Some are for entertainment, like this one. This is the infamous or famous, whatever you prefer, 2016 UK referendum, also known as Brexit, right? So point of this slide here is to illustrate that not necessarily we elect people all the time. Sometimes we vote on the policies, right? So that's also important to keep in mind. We're not only talking about elections of people, we're talking about procedures that allow us to make any kind of the decision, be that to elect a person or remain a member of European Union or decide to which restaurant we go if we are friends, right? So this one is another example of this is now from United States, is St. Louis municipal elections. What you have now, you have as many votes as you like. So this is something which is called approval voting, and it's getting more and more popular in recent times. So now, what it says here, vote for as many names as you approve of. You can vote for none, for one, for three, for five, whatever, okay? So this is, as I said, getting more and more popular because it's actually a voting system with very nice properties, okay? One more? Oh, this one is kind of special. This is 1936 German Reichstag election. As you can see, not much choice here, right? You actually have just one candidate, right? And all you're allowed to do is to vote for this candidate, right? So the purpose of this slide is, of course, illustrates that having a referendum or election is not necessarily means it's a democratic process, right? So we need to be very careful distinguishing the two. But in general, well, it's still election. Anyway, so why so many different voting methods? If you think about it, surely there must be one, the best one. Every country should use one, the best method to elect president, parliament, whatever, decide on a referendum on any issues or whatnot, right? Why people use different methods? So to understand, we need a mathematical model, okay? So now, and you do remember, right? You've been warned that we will have tests at the end of this class, right? And those who failed, they failed. I'm just kidding. Right. So mathematical model will be in three parts. We will only need three things. Ingredient number one, we will need alternatives. Right? Don't be afraid by the scary word finite set. It only means that there is some small number of the alternatives. It might be 1, 2, 3, 4, 17, but it's not infinitely large, right? And we will give name to those guys. It might be, you know, actual candidates or actual policies, but it doesn't matter, right? Because what we want to do, we want to construct a mathematical model. So we actually want to see how it works in general. So I will keep letters like A, B, C, D, and whatever comes next for the names of the candidates or policies or whatever we want to choose. Is that clear? Okay, good. As I said, those might be candidates, political parties, policies, or proposals of any kind. Second, we will have voters. Okay. So what do we need to know about the voters? It's a very simple thing. Every voter ranks the candidates' proposals, policies, or as we now call them, alternatives, right? From the most preferred to the least preferred, right? So every voter, the only thing we require of voters is that they actually made their minds. They know what they want, right? So they can rank the candidates or alternatives over which they want to vote, okay? So let's look at this table. What we have here, we have a society consisting of 4 people, right? You read this table column by column. So first column, ignore ones on the top for a second. So alternatives written in the first column are actually ranking by the first voter of the alternatives A, B, C, and D. As you can see, in these elections, we have 4 alternatives, right? A, B, C, and D. So first voter ranks them A, B, C, and D. The second voter ranks them B, A, D, C. The third, C, D, A, B, and the last one, D, C, B, A. Is that clear? That's how you read it, from the top to the bottom. Most preferred on the top, least preferred at the bottom. Right? So what are the numbers on the top? Well, numbers, we will be dealing with the larger societies very soon. So numbers represent number of people who have exactly the same preference, the same ranking of the alternatives. So here one says that we have only one person of this kind. In the whole society, we have only one person who ranks A, B, and then C, and then D. Is that clear? By the way, please don't be afraid. Interrupt me at any moment if something not clear. Just raise your hand and wave, and I will try to answer your question. Okay? But so far, everything should be pretty straightforward. Okay, good. So now that we have alternatives and the voters, we need just one last thing. We need a voting procedure. So what is the voting procedure? Voting procedure number 3. So for voters, all we need is ranking of alternatives. Right. And the final thing we need the voting procedure. Voting procedure takes the preferences of the society, rankings of the alternatives from the society, somehow does something, which we interpret as a counting votes, right? And then it spits at you the result of the elections. Okay? So think about it as a black box. Think about it as a meat grinder or sausage making machine, right? So you put ingredients on the left, right? Some kind of meat, spices, and stuff. And on the right, you get your sausage, right? So that's exactly what happens in the voting procedure as well, right? So there is a process in which people express their preferences. They submit it to the vote counting thing. And then after some time, we arrive at the collective decision. Is that clear? Good. So now what we will do, together, we will analyze the society, which has 55 people in it, and we will see what happens in this society if they vote according to the 5 different voting rules. Okay? And that will help us to understand why we need several different voting procedures. Okay, so this is our society. Now you can read, right? So question, how many alternatives we have in this society? 5, very good. And they, of course, named A, B, C, D, E, E, right? And how many voters do we have? 55, right? If you add numbers at the top, that's what you should get. You have 18 people of the kind A, B, D, E, and so on, 12 people with that kind of preferences, and so on and so forth. So now it's clear how we read society, right? Numbers on the top is number of the people having this particular ranking of the candidates, and the columns are exact ranking for the candidates. Extra bonus question. If we have 5 alternatives, what is the total possible number of all possible rankings? So here we have 6 different ones, right? As you can see. There are others, right? How many? 120, very good. So it's actually 5 factorial for those who are curious about it. Anyway, so our first system is plurality. Right? It's basically what we've seen already in some of our slides. Every voter gives 1 vote to their favorite candidate. Okay? And the candidate who receives the largest number of first places wins. Do not be confused about plurality and majority. Now we're talking about plurality. The person who gets the maximum number of votes among all the candidates, the alternative that gets the maximum number of votes, right? Not among the candidates, not the more than half, right? Okay, so let's see. That's our society. Everybody votes for the top candidate. So we have what? 18 votes for A, 12 votes for B, 10 votes for C, and so on and so forth. So who is the winner by plurality? Of course, it's A, because A receives 18 votes. Good? But now look at this society, please, carefully. Right? Mr. A, or alternative A, received 18 votes. But look at those remaining 37 people. They really hate A. Right? So maybe plurality is not always suitable for our purposes, right? So we elected here something that is really best for 18 people, but it's really worst possible outcome for 37 people. I mean, if you're not interested about 55 people, multiply everything by thousands, and then you have something to really care about, right? Anyway, so very popular procedure to ameliorate the problem with the plurality is to do something which is called runoff. By the way, this is a procedure used to elect the president of this university. So what happens in a runoff? First, everybody, as before, votes for the most preferred candidate. Okay? If there is a candidate who wins majority, meaning more than the half of the total votes, that candidate is elected. If not, like something that happened in our previous slide. Then we go to the second round. And in the second round, we eliminate all the candidates except two who received first and the second largest number of votes. And then the voting is only between two guys. Okay, so let's see how it goes. So that's again our society. As we know, that's the first round, right? A, B, C, D, E, right? And now what happens, because nobody got a majority, the two candidates with the maximal number of votes are A and B, right? So all the other candidates, alternatives, are eliminated. And now people vote in this way, right? All we need to do now is for every group of the people, compare A versus B, because it's now only two candidates we have, right? So if you think about the terms of ballots, what happens initially, you have a ballot with the 5 alternatives. So you vote, you choose your most preferred one, and then when election did not occur, we have no majority, then you get a second ballot. And the second ballot only will have two names, in this particular case, A and B. And those are the names of the candidates who in the first round got the first and the second largest number of votes. Is that clear? Yes? Okay, good. So who wins in this election? Well, A, as we know, always obtains only 18 votes because the other guys hate it, right? All the other guys, of course, would prefer B. So B is elected if you have a runoff. Good? Excellent. But sometimes people say, you know, why you immediately kept only two best guys? If you have maybe you already eliminated some good mid-range candidates. Let's try to go plurality, runoff, but slowly. Let's start to eliminate from the bottom. So in the first round, we will eliminate the person who got the minimal number of votes, right? So ballot shrinks by one person. In the next round, we again vote, and again, the person with the smallest number of votes gets eliminated. And so on and so forth, till we left only with two people, and then, of course, the outcome will be determined. Let's see what happens here. That's our society. The same, right? I'm keeping our society exactly the same. I'm only changing the voting procedures. Right? So what happens here, as we know, in the first round, as we can see, E is the candidate who gets the smallest number of votes, right? E only gets 6 votes, so E is eliminated. I eliminated E everywhere. Now we have this shorter ballot. Now what happens, A is still 18. B is now 12 plus 4. Why plus 4? Because it now receives votes from this group of people. Those guys no longer have E to vote for, right? So they now, of course, vote for their now current best alternatives. Okay? So that's the second round. What happens in the second round? D gets only 9 votes. Let's eliminate D. Third round. A 18, B 16, C 21. Wow, that was unexpected. Whom we eliminate now? B. Let's eliminate B. Now A versus C. Who wins? Of course, C. I think you're now starting to suspect something, no? I promised you 5 different voting systems, and we have 5 candidates. And what we've seen so far? A, B, C. Okay, let's see. So the next procedure is also extremely popular. It's not so much popular in politics, but it's super popular for electing the members of the committees and a small group like academic societies and stuff like that. So it was actually invented by, I will talk to you in a second about the history of the board account, but let me first go through the rules. Idea is something like this. It's basically the same idea as before. Try to weigh every candidate, try to find a compromise, right? Because sometimes, as we've seen, A is very good for somebody, but very bad for somebody else. So maybe there is a candidate who is in the middle, which kind of good for everybody. Not excellent, but good, right? So maybe that should be an alternative. And that's exactly what the previous methods tried to do, right? So board account does exactly that, but with a twist. It actually doesn't run into rounds. It's actually just assign some numbers, some scores or counts, and it's done in one round very quickly. And idea is very straightforward. You get points to a candidate based on how many candidates are below that candidate in your ranking. So if you have 5 candidates, your top guy gets 4 because there are 4 people above or below, sorry. The second ranked candidate in your list gets 3 and so on and so forth. Is that clear? Okay, good. So points added across all the voters, person with the maximal count gets elected. Okay, so let's relax a little bit from the very difficult mathematics, extremely difficult, right? Addition and multiplication. So let's talk a little bit about the history of board account. Interestingly enough, that system was invented at least 3 times independently, as far as we know. In 1433, a German bishop by the name Nicholas of Cusa proposed it as a way to elect the Holy Roman Emperor. So the Holy Roman Empire was an empire which comprised larger chunk of the modern Western and Central Europe. Germany, France, big chunk of Italy, big parts of Austria, and so on and so forth. Very big state. And it was very complicated because there have been a series of princes which have been called electors in the Holy Roman Empire, and they actually been casting votes to elect somebody. And always it was leading to the wars and conflicts and everything. So the system of counting the votes always was very important. And this bishop proposed a system which was effectively modern board account. But the system is named not after the Nicolas de Cusa. It's named after Jean-Charles de Borda, a French scientist. I think he was a naval captain as well. So in 1770, he proposed it as a way to elect members to the French National Academy of Sciences. And it's actually survived almost to this day, not for everything, but for the most things. It was partially abolished by the Napoleon, even though Napoleon himself was elected as a member of the French Academy of Sciences using the board account. That happens. Finally, 3rd time, this was reinvented by Charles Dodgson, probably more popularly known as Lewis Carroll, as the author of the book Alice in Wonderland and Alice Through the Looking Glass. And he was a Don at Oxford, so he proposed it as a method of elect faculty member, fellows actually, at the Christ Church College in Oxford. Okay, so very interesting long history, but let's apply it to our society. Okay, so let me check how we're doing on time. Good. So board account. So what we have here, let's calculate how many points alternative A gets, right? So it gets 4 points from 18 guys in the first column, and from everybody else it gets 0, right? Because it's the last candidate, nobody below, so score of 0 is awarded. Right, B, 0 times 18, clear? 4 times 12, 12 people who place it first. 3 times 10, 10 people who place it in the second position, so 3 candidates below. 9, so what we have, 1 times 9, why it's 1? Because there is 1 candidate below, right? So from that column you get 1 point, and we have 9 people with this kind of preferences, so you have 9 times 1. In the same way, you arrive at 3 times 4 and 1 times 2, right? So the first number is your score, and the second number is multiplication number of people who give you that score. Okay. If you do the calculation, you get 101 votes for 1. Sorry, score of A is 101. Okay, so let's look at, oh, I missed B, I guess, no? Yeah. Oh, that was B, right? A was easy. So C. Again, the same procedure, right? Now you should know it by heart, right? In the first column, it's 1 times 18. In the second column, again, 1, but now times 12. You do the multiplication and addition, you get 107. Okay? So we do it for C. We do it for D. We get 136. And then we do it for E. And we get 134. Remember, E was actually performing not so well in instant runoff, right? It actually was eliminated first because so few people put it at the top, but lots of people have it in the middle. So actually board account, the results are 72 for A, 101 for B, 107 for C, 136 for D, and 134 for E. So E is actually performing very well. But as I promised, 3rd election kind, and now we have 4th candidate, right? So we have A elected by plurality, B by the runoff, C by the sequential runoff, and D by board account. Okay, is it clear? Good. Now the last method which I want to introduce to you is called Condorcet winner. And the idea of the Condorcet winner is also very persuasive, very nice, and very compelling, I would say. So what happens here? So every pair of candidates is compared head to head. So if we have 5 candidates, what we will need to do, we will need to run, I don't want to calculate the number, we will cut it a little bit. So you need to look at all possible pairwise competitions. So it's as if you have a ballot in which only A and B is written, and then people vote on it. Then you have a ballot on which only A and C is written, and people vote for that, and so on and so forth. So you make all possible pairwise comparisons. Well, let's actually calculate how many we need to do in total, right? So first, in the first, you compare A with everybody else, so that's 4 comparisons. Then you compare the next one. You only have now 3 people remaining, then 2, and then 1. So that gives us 10. So you need to make, if I'm not mistaken, no. You have 10 pairwise comparisons to make. Okay? And if it so happens that there is a candidate who is better than everybody else in pairwise comparisons, that candidate is elected. And this candidate is called Condorcet winner. Right? So this procedure was proposed by these French philosophers and mathematicians with a kind of longish name, Marie Jean Antoine Nicolas de Carita Marquis de Condorcet. And of course, he was very active in the French Revolution. And as you know, Robespierre used to say the revolution eats its own children. So he was actually sentenced to be guillotined, of course, for his invention of the voting methods, I think. No, he was actually, presumably was accused of the tax fraud and other kind of things. But anyway, so he was put in Bastille, I think, in prison. Don't quote me on Bastille, in prison. And then in mysterious circumstances, he died. Some people, he said he committed suicide. Some people say the poison was sneaked into his cell or something. I don't know. Anyway, so, but he was a very brilliant mind. And it's actually one of book of Condorcet on election procedures are still very important for the political scientists. It has a lot of very important and useful ideas in it. And he is inventor of this very interesting and very nice method. So let's see what Condorcet tells us about our society. Okay, so because I know the trick, right? I know who wants to win in these elections. So I will not do all the 10 comparisons. I will choose one guy and compare it with everybody else. And if this guy wins all those pairwise comparisons, of course, he is a Condorcet winner. And of course, I will bet on E. Shouldn't be surprised now, right? So A versus E, what do we have? A, 18, E, 37. Okay, so E wins in a head-to-head comparison versus A. How about E versus B? B, as you can see, all the pairs for every person in bold, right? So B gets 22 votes from the second and the third columns. All other people prefer E over B, right? So we have now 33 votes for E and only 22 votes for B. Okay, the next one, E versus C. We have now 36 votes for E and only 19 votes for C. So E again wins. Finally, E versus D. Very small margin, just 1 vote, but E defeats D. 28 votes for E and only 27 votes for D. Okay, so E is our Condorcet winner. Okay, is it clear? Is it clear how all the 5 systems that I showed to you work? Okay, I hope next time when you are participating in some elections, you will recognize what kind of the election mechanism it is, what kind of election procedure it is. But now let's continue our discussion. So as we can see, we run 5 different things: plurality, runoff, sequential runoff, border count, Condorcet winner, and we got 5 different winners. Something wrong here, right? I mean, it shouldn't be that way, right? They all seems like a nice procedures to elect people, but they give a very different results. So it seems like a very strange situation, no? Okay, so 5 voting procedures, 5 different winners. Why? Well, the main idea behind every voting system, if you think about it, is the situation when everything works nice and smoothly. And this situation is the following one. Imagine that you have only 2 alternatives. So no matter then how many people you have, if everybody just votes for the most preferred alternative, you will have the person and it will be plurality, but at the same time, it will be majority, right? And the majority is something really, I mean, it's holy grail of the every kind of election procedure, right? If something delivers majority, then of course it's fine, right? You wouldn't be arguing with this one. Majority is really a very powerful thing. But unfortunately, as we've seen, in general, plurality fails to elect a majority candidate. Not always, right? For some societies, plurality elects majority candidate. But we've seen example in which plurality failed to elect majority candidate. Well, because there is no majority candidate. So all those procedures we've seen, 2, 3, 4, and 5, they try to help to overcome this problem. The first three procedures, runoff, sequential runoff, and border count, they somehow try to extend majority in a different direction. They say, okay, let's try to look for the compromise, trying to weigh all the candidates and compare them all together. So it actually throws more information into our machine, so to speak, right? On the other hand, the Condorcet method tries to do very different. It says, well, I like majority method so much, so let me just apply it every time for every situation, just comparing everything pairwise, right? Is it clear? So this is two different directions. On one hand, you have kind of what is usually called scoring kind methods, right? Which try to weigh all your preferences and somehow aggregate them into choice. On the other hand, another polar opposite is it's a Condorcet situation in which you really try to enforce majority as much as possible. And Condorcet method would be actually probably the best one possible because you cannot ever argue with the Condorcet winner, right? It's almost as good as a majority winner. But unfortunately, Condorcet winner very often fails to exist. And of course, you know one particular example of this one, right? It's called rock, paper, scissors, or junk and pour, right? That's exactly a situation when you have a cycle. So rock beats scissors, scissors beats paper, paper beats rock. All right? It's very easy to construct a society in which, let's look at this society. So we have only 3 people. Person 1 prefers A, B, C. Person 2 prefers B, C, A. Person 3 is C, A, B. Right? Let's compare A versus B. Oh, no, that one we're supposed to do by hand. Let's compare A and B. So as you can see, two people, first and the third, prefer A over B. So A is preferred to B. So let me write it here. A is preferred to B. Let's now compare B to C. We compare B to C, and we see that group 1 and group 2, both of one person, prefer B to C. So it's 2 versus 1. B beats C. But then now we compare C to A, and you see that the person 1 prefers A, but person 2 and 3 prefer C. So we have this infamous Condorcet cycle. A is preferred to B, B is preferred to C, and C is preferred to A. Whom should we choose? I don't know. Everybody wins in the pairwise comparisons, but nobody wins against every other candidate pairwise. So that's a big problem with the Condorcet. Unfortunately, it's very nice, but it easily may fail to exist. Okay, so then why not always use some kind of ranked voting, right? So we've seen runoff or border count. Why not something like that? Okay, because here another very strange thing might happen. So rock, scissors, paper example you knew before, but this one you probably haven't heard about before. This is something which is called independence of irrelevant alternatives. So let me tell you a short story to illustrate what it means when we violate independence of irrelevant alternatives, IIA, okay? So imagine you come to a restaurant, and this restaurant only has 3 choices: meat dish, fish dish, and vegetarian dish, okay? And suppose the person, the customer, sits down, look at the menu and says, I will have meat, okay? So the waiter, records the thing, goes to the kitchen, but returns in a second and says, sorry, the vegetarian dish is no longer available. The customer says, well, in this case, I will have fish. What? Why? So that's exactly a violation of independence of irrelevant alternatives. What happens here? Imagine like this. You have a ballot on which you written 3 candidates, meat, fish, and vegetable, right? If you written 3 names of this one, the customer will elect meat. But if you erase one of the candidates which haven't been chosen by that customer, the customer changes his choice. So this is almost as bad as have a Condorcet cycle. So this is independence of irrelevant alternatives. You put alternatives on the ballot, which are irrelevant, you would never choose them, but the very fact that they are present on the ballot changes your decision. And this is a very serious problem as well. And that's exactly what is all the scoring methods are guilty of. They very often fail to satisfy, not always fail to satisfy independence of irrelevant alternatives. Yes, please.
Isn't that somewhat negated if there's a rule that says you don't have to give a ranking to every candidate? So like, there's 17 candidates, but I only like 3.
Exactly. So that's why approval method is actually now getting more and more popular, right? So we're now only looking at this class of ranking methods in which you're actually supposed to choose one candidate to give a ranking to the whole thing. Right. Very good point. Thank you. I will come to it in a second. Right. So it seems now we know what the ideal method, voting method should be, right? We solved actually the problem, right? Because we identified all the things we want to have, right? We want to get majority winner when one exists. We want to get a Condorcet winner if one exists. And we don't want ever violate independence of irrelevant alternatives, right? That's our requirement now for the election system, right? If we're able to do this kind of thing, well, not precisely, but roughly, right? That would be seeming like a very good voting method, right? In 1951, a person named Kenneth Arrow proved that such a voting method does not exist. It's impossible. If you want for every possible profile of preferences to go in this voting method, there is no way to aggregate individual preferences in such a way that you always have a Condorcet winner if one exists and you never violate IIA. Well, in fact, there is one method which foolproof. It's called dictatorship. But somehow people don't like this one. Right? In 1972, for that work and for the other, Kenneth Arrow got a Nobel Prize Memorial Nobel Prize in Economic Sciences. So why democracies vote in so many ways? Because there is no best way to vote. Depending what kind of sacrifices you want to make, what kind of compromises you want to make, you come up with the different methods. And that's why we're still inventing new voting methods almost as we speak. So as I mentioned, something which is called approval voting, which is more recent, probably most recent of all the voting methods. In a way, it's a way in which you can give any number of votes, as we've seen in the St. Louis ballot. You can give any number of votes, and then you count them and so on. So that's probably one which is very resilient and stable voting method. But still, we cannot say it's the best one, because even this one sometimes would run into some problems. Because why? Because Arrow told us so. He proved it mathematically. There is no way to reconcile independence of irrelevant alternatives and Condorcet winner. You always run into a problem, at least with some societies. Of course, some of those societies are very strange, but I mean, you need to have a really foolproof method anyway. So that's it. Thank you very much. So I hope you got at least some. Let's get. I hope you got at least some idea how mathematics is helpful for the analysis of the electoral systems. Okay. We probably have a time for one quick question, right? Or maybe two. Any comments, questions, concerns? Okay, thank you.